Hi everyone, welcome back to my channel. So in today's video we are going to discuss about how to develop a test bench code for Fifo. Okay, here we are already having the RTL code. For this RTL code, you and I together will be developing SV test bench code for the Fifo. Okay, you already know about Fifo. It is first in, first out. Right, so we are going to develop a SV test bench code for this Fifo. And before going into today's session, firstly, I'm sorry for not uploading videos regularly because presently I'm very busy with the one-to-one tutoring sessions for students. So, which is why I couldn't afford time to edit the sessions and upload in the YouTube channel. But presently I'm free, which is why I'm going to upload the sessions on System Verilog as well as UVM mostly regularly, right? So sorry for that, for the long awaited sessions on this in this channel. And also, if you are new to this channel, consider subscribing my channel and hit on the notification bell also. And if you are someone who are looking for the paid tutoring sessions on design and verification courses like System Verilog and UVM, you can contact me through my LinkedIn ID. The LinkedIn ID is in my YouTube channel. You can go there and subscribe it, and then you can follow me on the LinkedIn. And also, I'll be posting regularly in my LinkedIn, as well as I'll be having the courseware uploading in my Telegram channel. You can also join my Telegram channel. The link is also in my YouTube channel, right? So yes, let's get into today's video. So we are going to develop test bench code for Fifo. So for test bench code, we will be writing various files like transaction, generator, driver. So all these things. You already know about how to develop a code for this test bench architecture. If you don't know about that, I'll link the video in the description box. You can go there and check it out. Like how to have a, just I have given a basic idea on how to develop a code in System Verilog test bench architecture, right? So you can go there and check it out and then view this particular video, right? So coming to FIFO, first we'll be creating the transaction file, right? So transaction dot sv, right? So this is my transaction file. So what does the transaction file consist of? Basically, the transaction file consists of all the inputs. Transaction is nothing but packets of data, right? So it consists of data. Data is nothing but inputs and outputs, right? So basically, the transaction file consists of all the input and output signals that are present in your RTL design, right? And also, if you put any constraints in that, you can just add in this transaction file. So these are the basic things that the transaction file consists of. So what are the inputs and output signals here? Here, write enable, read enable, and write data. These are the input signals. And full, empty, and write data, read data. So these are the output signals. So all these input and output signals will be mentioned inside transaction file, right? So if you see here, this is my transaction file. So this is the class. Okay, so here if you see the signals, write enable, read enable, and write data, these are input signals. So in transaction, all the input signals need to be randomized. So in order to randomize, we need to mention the ran keyword before the particular variable, right? So this read enable, write enable, and write data are ran bits because they are input signals. And when it comes to the output signals, write data, full, and empty, they are just bits because we only need to randomize the input signals. We don't randomize the output signals, which is why only read enable, write enable, and write data are ran bits, and read data, full, and empty are not ran bits, right? So this is what my transaction class consists of. So along with this, if you have any constraints, so basically we are writing the FIFO code, right? So there should be some limitations when we are entering or reading the data. What is the basic limitation? When we are writing something into the FIFO, then the read operation should not be enabled, right? And when we are reading something from the FIFO, the writing into the FIFO should be avoided, right? So this is the main thing that we need to consider. For this particular condition, I am writing a constraint. So what is the constraint that I am writing here? Constraint with some name. Okay, so what is the condition here? Read enable is not equal to write enable. That means when you are reading, write enable should be 0. When you are writing something, read enable should be 0. Right? So this is the constraint that I am using in my transaction class. So as for now, this is the thing that is contained in my transaction class. Right? So this is the basic transaction class that in any code consists of. So basically the transaction consists of all the input and output packets of data, and if you have any constraint limitations, you will be mentioning it within your transaction class. This is the basic thing that your transaction class consists of. Now the next thing is you need to transfer this transaction class from generator to driver, right? So the next thing you need to create is generator file, generator.sv. Okay, so within this generator, so what we have in this generator, basically in generator we need to transfer the transaction. So obviously we'll be having the transaction class, right? And then you need to transfer the transaction. So in order to transfer the transaction from generator to driver, you need something, you need to transfer. In order to transfer, you need a source. So what is that source? That is mailbox. Okay, so you will be creating the mailbox, and then you will be putting this transaction within the generator, and you will be getting that transaction from the generator, right? So basically you need two things. First is the transaction, and then the mailbox. And what you will be doing, you will be creating the constructor function for both of these transaction and sorry, for this mailbox. Okay, so this is the basic thing that you will be writing in the generator. Now let us see how we are going to develop a generator code. So this is my generator class. So what does my generator class consist of? It consists of transaction. Okay, so you will be including the transaction file, include transaction.sv. Okay, so along with including this file, now what you will be doing, you will be writing the class. Okay, class generator. And what you will be doing, you need to create the handle for the transaction. So what is the transaction that you have taken here? Transactor is my class. Okay, so the name of my transaction is class transactor. So for this transactor I am creating the handle. Okay, so you already know that class is the user defined data type. So here in this particular transactor, here you are using it as user defined data type. Okay, so this transactor is a data type with variable trans. Okay, so for this trans I am randomizing. Why you will be randomizing? Because transaction is nothing but packets of data. So you will be having some packets, some 4 or 5 packets of data, any number of packets of data. So among these packets of data also you can randomize some different packets of data, which is why you are giving this trans as rand bit. Okay, and then the next thing is you need to create the mailbox. So this is my mailbox, which is gen2 drive, mailbox gen2 drive. Okay, and then these two things, in repeat count, in repeat, we'll be discussing it later, like why do we use these things, right? Now what I am doing, after creating the generator mailbox, I will be creating the constructor function for this mailbox. You already know about how to write a constructor function. Okay, I have already explained it clearly in the classes. If you don't understand it, I'll link that in the description box. You can go there and check it out. Like how to write a constructor function. Okay, so basically you are writing the constructor function for this mailbox, right? And now coming to the main task. So what is the main task here? You need to put the transaction. Okay, you need to put the transaction uh, in the mailbox. So that is the main task of the generator, is it or not? So for this main task I am writing a code. So what is my code here? Okay, so repeat count. Here I am taking a variable named repeat count. Okay, so why I am taking this particular variable repeat count? Because I am randomizing it. Okay, here basically instead of repeat count you can use any number. Repeat 5 means how, what will happen, the randomization will be taking place for 5 times. Okay, so simply in order to randomize it number of times, what I am doing, I am just taking a variable repeat count. Okay, instead of just giving a simple number, right? So repeat count, that is why I'm adding a variable repeat count here in repeat count. right? So for this in repeat count, I am just repeating 5 times and or 10 times any time. And now what I'm doing, I'm creating the handle for my transaction. Okay, so this is my transaction, right? Transaction with the handle trans. So I'm creating the memory for this trans, which is new. Okay, now I'm going to randomize. So for this randomize, you can either use this in this way, like here, instead of writing all this entire thing, like if you see here, instead of writing all this entire code, you can just write it as trans dot randomize. That is also fine. Okay, trans dot randomize. If you are just giving it like this, then also the code will be fine. But what I'm doing is, instead of writing trans dot randomize, instead of randomizing the transaction directly, okay, I want to know every step whether randomizing is happening or not. Okay, so in order to know whether randomization, after running the code, whether randomization is happening or not, in order to know that, I am writing a particular if block where if not trans dot randomize, that means if randomization is not done, then you will get the fatal error. Okay, so dollar fatal, what it will be happening, it will be showing me the error that packet is not randomized. Okay, else, that means if trans dot not randomized means randomization is happening, so randomization is successful. Okay, so in this way, what I am doing here, I am writing a loop where the randomization is happening, and if there is, if for example here I am repeating for 5 times, right? That means I am randomizing the transaction packet for 5 times. So when I am randomizing the packet for 5 times, if only 4 times the randomization is happening, and if the fifth time the randomization is not happening, how will I understand whether the randomization is happening or not, right? So in my log file, if you are writing this like in this manner, like if I am writing the dollar fatal and dollar display, so what happens, then I can understand whether my randomization is happening clearly or not. So basically in any generator you will find it in this way only. Instead of trans dot randomize, okay, you will be writing in a professional code, you will be writing it in this manner, like if not randomized, then you will get a fatal error, else you will be getting that randomization is successful. So after randomization is successful, again it will be going for another packet, right? So that means what, plus plus count. So I am taking another variable count in order to represent whether the packet is successfully randomized and what is that packet that was randomized. Okay, so in order to display that, I am just taking another variable count and then I am just looping it. Clear? So this is what my generator transaction packet is done. Now after transaction dot randomize, that means after transaction is randomized, now what happens, you have randomized that particular transaction. Now what you need to do, you need to put that transaction in the mailbox. So how are you going to do it? So what is my mailbox? Gen2 drive. So for this Gen2 drive, I am just putting my particular I'm just using dot put, okay, with the transaction. So gen to drive dot put transaction. So now when you are giving this command, what will happen, the transaction is put in the mailbox, right? So this is what my task is, end task, right? So this is what my generator block consists of. Basically in any generator block, this is the thing that you will do. The main advantage of system verilog test bench code is, most of the code, like from transaction in the generator and as well as in driver, most of the code is same for every SV test bench development. Okay, for any code, like for any, either it is FIFO or either it is adder or either it is memory or any code, the base will be same. So what is the base? For transaction, the base is all the input and signal, all the input and output signals. Even though input and output signals variables or something are different, but basically all the inputs are given for ran bit and all outputs are given without any rans. And then if based on constraints. If you are having any limitations, you will be writing the constraints. That is the standard in transaction. Now coming to generator, what is the standard things in the generator? In generator you will be using the transaction class, okay, and then you will be creating the handle for transaction, as well as you will be writing the mailbox, and then you will be using the constructor function for the mailbox, and then you will be just what is the main task? In the main task you will be randomizing the transaction, and then you will be putting that randomized transaction in the mailbox. That is the standard thing in the generator, right? Now what do we need to do? We need to send this transaction from generator to driver, and within the driver what you will be having? You will be having within the driver you will be getting the things that are present in the generator. So you need to create the mailbox in the driver, and along with the mailbox you need to create a virtual interface, because from driver you will be sending it to the RTL, right? You will be sending the information from driver to the RTL code through interface. So you need to have a virtual interface in order to transfer the information from virtual interface to the interface, and from interface to the RTL. So basically before writing the driver code we will be writing the interface code, right? So let us create the interface file, interface.sv. Okay. So coming to my interface code. So what is the interface code basically consists of? Interface is nothing but it's a group of signals, is it or not? You will be packing all the signals within the interface, and then you will be sending it from one component to another component. So it consists of all the input and output signals, everything. Every signal that is consistent in your RTR code, that is present in your interface. So basically if you see here you will be writing with the interface keyword, interface, okay, interface name, like Fifo if is my interface name, right? So in this, within the argument you are mentioning the clock, okay. Within this argument you can either mention clock as well as reset also, both things you can mention, or you can mention just only one thing, right? So clock, and then all the input and output signals will be mentioned here with the logic. Basically in interface we will be using only logic, okay. There is no particular reason that we need to only use logic, but basically since logic acts as both wire and register, mostly we will be using within the interface we will be using only logic data type, right? So within this, see, clock, reset, read enable, write data, read data, full empty, all the signals were mentioned, right? So basically if you are writing just a code like adder or memory, you will be using only interface signals, okay. But in FIFO we will be adding some internal touches also, like we will be writing some clocking blocks, as well as you will be writing some mod ports, okay. Basically what is the use of this clocking blocks and mod ports? Mod ports is used to know the, give you the direction of the particular signals. Basically if you see here, read enable, write enable, so these are the signals within the interface, okay. And you will also mention the direction of these signals within the clocking block, as well as mod ports within the interface. So here for this signals, directions, as well as for the clocks and all, I am mentioning the clocking block as well as mod port. So within the clocking block, how you are going to write a clocking block? Okay, you will be using the keyword clocking and end clocking. So within the clocking block you are just giving a name, okay. This clocking block name is driver CB, okay. For every passage of clock within the clocking block, okay, so the default skew rate time is input is #1 and output is #1. So the clock basic default delay is #1 and #1, okay. So if you see here, this is the driver clocking block. So when it comes to, you just listen this carefully before understanding this, okay. From driver you are sending the input signals, like what are the input signals here? Read enable, okay, write enable, as well as some write data. So these are input signals. So what are the input signals? All these input signals you are sending from driver to RTL DUT, right? So that means you are taking, you are giving it. That means they are basically whatever that are given as input in the RTL, those are mentioned as output when it comes to driver clocking block. Okay, so the direction of those things are output. So here if you see, reset is the input, write enable, read enable are inputs, and write data is input. So all these will be mentioned as output with from the driver point of view. Okay, so since you are writing the driver clocking block here, from driver point of view, all these reset, w data, read enable, and write enable, all these are output signals, because the driver is sending all the signals to the DUT. That means it is giving the signal. So that is why it is, since it is giving the signals, and the DUT is receiving the signal. So that is why that is output and this is input. Okay. Now coming to full empty and write data. So these are basically mentioned as output within the RTL signal. So what is happening? They are mentioned as opposite way, like input in the drive from the driver point of view. Okay, these are mentioned as input in direction. Clear? I think it is clear for you why we will be mentioning in the opposite way in the clocking block of the driver. From the driver point of view, all the input signals from the RTL are outputs, and all the output signals in the RTL code are inputs, right? So this is the thing. Now similarly we'll be writing the clocking block for monitor, because basically here if you see in the interface, interface is basically two way, like through interface you will be sending the data from driver to the DUT, and through interface itself we will be receiving the data from DUT to the monitor, right? So you will be writing both, from driver point of view how the interface is going to act, from monitor point of view how the interface is going to act. Okay, so you will be writing two clocking blocks for both driver as well as monitor. Now coming to the monitor clocking block. Okay, here for monitor clocking block I am just naming it as clock monitor. For every passage of clock, okay, since the it is getting in the output, we don't need give any clock rates here. Okay, because if you see here in monitor, all the signals like reset, read enable, write data, full empty, all these are input signals. Why? Because okay, after driver is sending all the inputs and outputs from driver to the uh, DUT. In the DUT, the calculation is completed, right? With this logic, you will be writing some logic within the DUT, right? So within this logic, all the calculation is done, and then after everything is done, all the input signals and output signals are sent to the monitor. Is it or not? So the DUT will be sending everything that it has calculated to the monitor. So whatever the monitor is receiving, all it is receiving. Okay, it is not sending anything to again DUT. It is not sending anything. It is receiving everything from the DUT. That means since everything is received from the DUT, basically all the signals are mentioned as inputs in the monitor from the monitor point of view. Is it clear? So basically this is what happening. Okay, when you are mentioning in the clocking blocks, this is the thing that you should remember. When you are mentioning the um, directions within the clocking block, okay, the main difference that you need to consider is when you are seeing from the direct driver point of view, from driver point of view, all the input signals that you are mentioning in the RTL are given as output, and all the output signals are given as input, right? Now from the point of monitor, all the signals are only input signals. There are no output signals within the monitor. Why? Because everything is received from the DUT. Okay, the monitor again doesn't send anything to the particular RTL. Okay, it will only be receiving everything from the RTL. So that is why all the signals are considered as input in the monitor clocking block. Whereas in driver clocking block, they will be vice versa. Okay, so this is what clocking block of monitor and driver. Now, okay, you can just mention the clock within the signal only. But here, what I am doing, I am just writing the mod port again. Okay, just you will be using all the clock. But in this way, when you are writing the code, you can understand how can you use both clocking blocks and mod ports within the interface. Okay, so here I am writing the mod port for my driver and monitor. Okay, mod port with the name driver. Okay, anything you can mention, either driver or anything. Here I am just mentioning it as mod port driver, and within the driver what I am calling within the arguments. Okay, within the arguments I am calling here mod port driver. Within the arguments I am calling clocking block. Okay, so clocking is nothing but this clocking block, and I am calling the driver cb. Here if you see, this is my driver cb is my I'm calling this particular driver CB. Now what happens? All the signals within the driver CB will be called here. Okay, with this mod port, right? And then along with it, I am just mentioning the clock's direction here. Here the clock direction is input. Okay, similarly, mod port for monitor, mod port clocking monitor and input clock. Okay, so you are calling clock by using the mod port, and you are calling the remaining all within the clocking block. Okay, so basically this is what your interface consists of. Clear? And then in the next one, so this is all the important things within the, sorry, three important blocks within your system verilog test bench code, and then the remaining driver and generator scoreboard. So all this will be discussing in the upcoming sessions. Okay, please do wait for the upcoming sessions. And also if you are having any doubts in this particular video, you can ping me in the comment box. I'll definitely answer your questions. And also please do remember that I am presently offering the one-to-one sessions for paid tutoring sessions. If you are interested, you can contact me in my LinkedIn ID. And that is all for today. Thank you all.